Means what? When you do intersection, you should get null set. Sample space and event, both the sets, if they are equal, we call them a sure event. When can you say two events are mutually exclusive? We can say two events are mutually exclusive if they don't have any common elements. Means when you do intersection, you should get null set. A minus C means from A, remove the elements of C and write the remaining elements of A. Dear student, mutually exclusive means they should not have any common elements. Welcome to the session, dear students. Today we'll go ahead with the problems of probability, that is exercise 16.2. So now problems of 16.2. A die is rolled. Let E be the event, die shows 4, and F be the event, die shows even number. Are E and F mutually exclusive? See, in the question they gave two events. Event E they mentioned a die shows 4. So means event E is what? 4. All of you know when you roll a die, the sample space what you get is what? 1, 2, 3, 4, 5, 6. This is the sample space. And event E is what? Getting 4. And event F also they define. Event F they told. Event F shows even number. Die shows even number. What are the even numbers? 2, 4, 6. Now the question is, are they mutually exclusive? E and F, are they mutually exclusive? What is meant by mutually exclusive? Two events are said to be mutually exclusive if they don't have any common elements. Means what? When you do intersection, you should get null set. Okay, now let us do intersection. Find E intersection F. All of you know set theory. Intersection means what? You should write the common elements. So in E and F, we have element 4 which is common. E intersection F is equal to 4. And this is not equal to null set. So we have E intersection F one element. It's not a null set. Therefore, E and F are not mutually exclusive. They are not mutually exclusive. Not mutually exclusive. When can you say two events are mutually exclusive? We can say two events are mutually exclusive if they don't have any common elements. Means when you do intersection, you should get null set. But here we are not getting null set. We are getting an element. Therefore, they are not mutually exclusive. So, a die is thrown. Question 2. A die is thrown. Describe the following events. Event A is A number less than 7. Event B, number greater than 7. Event C, multiple of 3. 3 events they want you to describe. And also find A union B, A intersection B, B union C, A minus C. So dear students, first let us describe the events. So first one, event A. Event A is what? Number less than 7. So when you roll a die, what are the possible output? Sample space of the experiment throwing a die is what? So when you throw a die, sample space is 1, 2, 3, 4, 5, 6. So you'll get 6 elements. And A is what? Number less than 7. So what are the numbers less than 7 in this? 1, 2, 3, 4, 5, 6. These are the numbers less than 7. Event B. What is event B? Event B, number greater than 7. So when you roll a die, you will get 1 to 6. You cannot get a number greater than 7 when you roll a die. Therefore, event B is a null set. So it does not have any element. It's a null set. And event C, multiple of 3. Event C, they told a multiple of 3. So what is event C then? Multiple of 3 means what are the multiples of 3? 3 and 6. These two are the multiples of 3 when you roll a die. So dear students, they want you to describe the events. I have done description of the events. First one, number less than 7. So you will get the whole sample space as set A. So I can say set A as sure event. What is sure event? A event whose output is same as sample space. Sample space and event, both the sets, if they are equal, we call them a sure event. Event A is a sure event. And event B, they told number greater than 7. We don't have any number greater than 7 when you roll a die. So therefore it's a null set, empty set. And event C, multiples of 3. What are the multiples of 3 in this? 3 and 6. Multiple of 3 we got. So I described. They want you to describe the events. We have done it. So then also find A union B. The first part, A union B. We'll find A union B. All of you know union. Union means what? Combine two sets without repeating. A is 1, 2, 3, 4, 5, 6. B is null set. When I combine, I'll get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So always a set union subset is always a set itself. Null set is a subset. So A and B, if I combine, I'll get A. So it is same as A or S. We can also say this is equal to A, or this is also same as S. Then we are done with A union B. Then they want A intersection B. What is meant by A intersection B? Common elements of A and B. All of you know set theory. In set theory, intersection A intersection B means you should write the elements which are common in A and B. Means we should write the elements which are present both in A and B, which are common to A and B. So A is 1, 2, 3, 4, 5, 6. B is null set. So we don't have any common element. So it's again null set. Any set intersection null set is null set. A intersection B is null set or empty set. You can write like this, or you can write the symbol. So they want B union C. What is B, dear students? B is a null set. This is B. And C, what is C, dear students? C is multiples of 3, that is 3, 6. They want B union C. B means combine B and C, will get 3, 6. I can say it is same as C. This is the answer. Then apart from that B union C, they want A minus C. A minus C. So what is set A? If you observe, set A is 1, 2, 3, 4, 5, 6. Minus C we need to do. What is C? And C is multiples of 3, that is 3, 6. C is 3, 6. Now I should do A minus C. A minus C means from A, remove the elements of C and write the remaining elements of A. So 3, 6 you should remove. 3 and 6 from A you remove. So write the remaining elements of A. What are the remaining elements of A? 1, 2, 4, 5. This is A union C. A minus C. So now we are done with A minus C also. We got what is A union B. Then we got what is A intersection B, B union C, A minus C. I hope all of you got it. Means it's a combination of set theory as well as probability. So rolling a die, sample space we got, and set A, that is numbers less than 7 means all 6 will get. Set B, number greater than 7, null set, and set C, multiples of 3. And then A union B, union means combine, intersection means write the common elements, difference A minus B means A minus C means from A remove C and write the remaining elements of A. Next we have a die is thrown, describe the events. Event D. Event D, a number less than 4. See, first before we go to any problem, write the sample space. What is sample space when you roll a die? 1, 2, 3, 4, 5, 6. These are the possible outputs. And D, what is D? Number less than 4. What are the numbers less than 4? 1, 2, 3. Event E, what is event E? Event E, an even number greater than 4. Even number greater than 4. So this is 4, greater than 4, only one even number we have, 6. They want a number which is greater and even number, they mentioned even number greater than 4. So only one even number we have, greater than 4, that is 6. Then event F, a number not less than 3. A number not less than 3. It should not be less than 3. So not less than 3. 3 is not less than 3. 4, 5, 6. 3, 4, 5, 6 including 3. These are the numbers not less than 3. Now what they want you to find? E intersection F they want. They want you to find E intersection F. What is meant by intersection? We read this as intersection. Intersection means common elements present in both E and F. What are common elements in E and F? In E we have 6. F also we have 6. Common element in E and F is 6. So E intersection F is 6 and it is same as E, you can see, set E. So we are done with E intersection F. Then they want you to find D intersection E. They want you to find D intersection E. Means they want you to write the common elements of D and E. They want you to write the common elements of D and E. So in D we have 1, 2, 3. In E we have 6. Do we have any common elements in D and E? We don't have any common elements. So D intersection E, since we don't have common elements in D and E, it's a null set, empty set. So we can write psi. So we are done with D intersection E. They want D minus E. They want what? D minus E. D minus E means from the set D, remove the elements of E and write the remaining elements of D. What is D? 1, 2, 3. What is E? 6. From I should remove 6. Do we have 6 here to remove? No. D minus 6 gives you 1, 2, 3 only. Because I am supposed to remove 6 from this, we don't have element 6 in this D. We don't have element 6, so it will be 1, 2, 3 itself. So it is same D. So we are done with this. E intersection F dash. First we need to find F dash. What is meant by F dash? In set theory we say U minus F. But here U means universal set, that is sample space. Sample space minus F. What is sample space? 1, 2, 3, 4, 5, 6. In this you should remove what? F. What is F? F they define not less than 3, that is 3, 4, 5, 6. F is 3, 4, 5, 6. And you got F dash. F dash means from S, that is universal set here is sample space. From the sample space remove 3, 4, 5, 6. If I remove this 3, 4, 5, 6, 3, 4, 5, 6, if you remove, I am left out with 1, 2. 1, comma 2 is F dash. Now they are not interested in F dash, they want F dash, we are done it. Then E intersection F dash. E intersection F dash means common elements of E and F dash. So let me write E. What is E? What is E? Here we have written 6, that is even number greater than 4. So E intersection F dash means common element of E and F dash. Do we have any common element in E and F dash? We don't have any common element in E and F dash. E intersection F dash is null set. E intersection F dash is null set. So we are done with this. I hope all of you understood this. Then an experiment involves rolling pair of dice. We'll roll 2 dice, recording the number that comes up. Describe the events. Which of this pair of events are mutually exclusive? So first they asking you to describe this events A, B, C, and in this which pair is mutually exclusive they are asking you. First let us describe the events. So before I go to this sample space I'll write. So when you roll a die you will get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then 2, 1, 2, 2, goes on till what? 6, 6. So how many outputs you will have? So one die, if you roll 6 outputs, 2 dice means 6 square, 36 outputs you will have. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 4, 3, 5, 3, 6, and like similarly till 6, 6. Coming to this, they told event sum is greater than 8. So sum is greater than 8. So I will pick those events, sum should be greater than 8. I cannot take 1 with 1 combination because 1, 6 gives you 7. With 2, 2, 6 gives 8. I will take 2, 3, 2, 7. 2, 7 can't be taken. Can we take 2, 7? No. Die contains only till what? 6. So 2, 6 if I take, it should be greater than 8. Not possible. So in 2 also I cannot get anything. 1 also I can't get anything, and 2 also I can't get anything. So with 2 we cannot. So start with what? 3. So 3 plus 6. So one die output is 3, 3, 6. One pair 3, 6. It's greater than 8. And that's it. And then with 4. With 4 if I take 4 comma 5. 4, 5, 4 plus 5 gives you 9. 4, 6, 10. So greater than 8 I want. Then it can take with 5. With 5, 5 plus 4, 5, 4, 5, 5, 5, 6. All these outputs gives sum greater than 8. Then with 6, you can take 6 with 3, 6 plus 3 is 9, 6 with 4, 6 with 5, 6 with 6. So these are the possible outputs for set A. Set A means what? Sum should be greater than 8. If I take a pair, the sum should be greater than 8. You can take any pair, sum is greater than 8. And then B, 2 occurs on either die. 2 occurs on either die. Means what? 2 comma 2. Only one such output. C, sum is at least 7 and multiple of 3. When you add, it should be at least 7, means it should be 7 or more, and that sum should be multiple of 3 also. At least 7 means 1, 6 if I take, 1 plus 6 becomes 7. Yes, 1 plus 6 is 7, but it's not multiple of 3. 1, with 1 we can't get anything. 2 I'll take. 2 plus 2, 5 gives you 7. 7 is not multiple of 3. 2 and 7 if I want. 2, 5 if I take 7. 2, 6 if I take 8. 2, 6, that's it. So with 2 is also not possible. Suppose if I take 2, 6, if I add 2 plus 6 gives you 8, it is at least 7, greater than 7, 7 or greater, but it's not multiple of 3. It should be multiple of 3, they told, no? So I can take it. So at least, and I should go with the 3. See, 3, 5 if I take, it is more than 3, 4 is 7, 3, 5 is 8. 3, 6 I can take, because 3, 6, it is, sum is at least 7, means equal to or more than 7. And also it's multiple of what? 3. What is 3 plus 6? 9. 9 is greater than 7 also. It means it holds good at least 7 also. And it's multiple of 3 also. And with 3 we cannot take more. That's all, 6. Then with 4. 4, 4 gives you 8. 4, 5 gives you 9. 4, 5 is possible. Then with 4, 6, 10, no. With 5, 5, 4 you can take. With 11, no. With 6 I can take 6, 3. With 6 I can take 6, 6. So now this C, the sum is at least 7. When you add, the sum should be 7 or more. It is 7 or more. At least means what? That much or more than that. So all of them will give you more than 7. And all of them will give you a multiple of 3 when you add. So this is C. Writing C is important. So A, B, C I wrote. Now we'll see which pair are mutually exclusive. Dear student, mutually exclusive means they should not have any common elements. A and B. 2, 2 we have here, and we don't have 2, 2 here. So A and B are mutually exclusive. From the sets, A and B are mutually exclusive. What about A and C? A and C, no. We have common elements, 3, 6. What about B and C? B and C is also mutually exclusive. B and C are also mutually exclusive. So, mutually exclusive, we have 2 pairs. One is AB, the other one is BC. A and B are mutually exclusive, B and C are also mutually exclusive. And A and C are not mutually exclusive. And they want you to find which of them are mutually exclusive, that's it. AB and BC are mutually exclusive. Which are not mutually exclusive? A and C, these two are not mutually, but these two are mutually and these two are mutually exclusive. What are mutually exclusive events? 2 events are said to be mutually exclusive if they don't have any common elements. Here A and C do not have any common element. B and C do not have any common element. So pair AC and pair BC are mutually exclusive. The basic is mutually exclusive. What is meant by mutually exclusive? We can say mutually exclusive. Become thorough with this. 2 events are said to be mutually exclusive if they don't have common elements. Means if A and B are mutually exclusive, then A intersection B should be null set. And if you see, we also found out F dash today. F dash means what? S minus F. Here we will have universal set as sample space. So all this kind of problems we have done. Please sit and revise them. I'll see you in my next session. Thanks for attending. Thank you.